Hi, in this video I'm going to show you how to use NC capture melt single with a more complicated example than the iris data that we were talking about earlier. So yeah, this one, if you look on the man page, there's an interesting example that's related to a data set from the World Health Organization. So here I got this example from the tidyr package, which provides this data set. And so they have some similar ways of manipulating this data set. But so we're gonna show how to do the same thing using NC. So here I'm gonna load the data set, and so what we're gonna do is we're going to let's take a look at the column names of the WHO data set. There's a lot of them. So one thing that you can see is, well, there's a few columns: country, ISO, 1, 2, 3, year, and then there's a bunch of them which match some kind of regular expression pattern, or we're going to match with a regular expression pattern. So to do that, let's use capture melt single. So the reason why we do this, let's take a look at this data set. Let's convert it to a data table. Well, I don't have loaded data table yet, so let's use it like that. So in that data table, you see that there's a bunch of numeric measurements that we make. These new variables. We don't see all of them, but we do see that for a few of them, there are these numeric counts that we might want to, we might want to make some comparisons about, right? So, for example, if you wanted to make some kind of, time series plot with different age groups in different colors, you would want to well, so for example, the age groups, so this is the 0 to 14 age group, this is the 15 24 age group, etc., 25 34 age group. If you want to make some kind of time series plot with all those different age groups and different colors, what you would want to do first is you want to reshape this data table so that you have, instead of lots of different instead of having those age information encoded in the column names, you'd have that as a separate column by itself, and then we can use that new column to encode the color information. So let's see if we can do that. So to use capture mount single for that purpose, what we do is we provide the data set as input, and then all the rest of the arguments are going to be a regular expression that is going to match the different columns, the different column names that we want to melt or reshape. So that's going to be pretty easy. What we're going to do is we're going to use new, and so yeah, let's go to this definition. So sometimes there is a underscore, sometimes there's not, right? So because of that, basically we can put a question mark after the underscore, so then it's going to match in either case. Then after that, there's this SPEP thing, which is going to be a diagnosis variable, which we see in the help file, right? So to match that, we could call that a diagnosis in this World Health Organization data set. I guess it's the count of people diagnosed with a certain diagnosis. So here I'm going to use dot star to match anything in there. Then I'm going to use underscore, because it seems like there's an underscore after every one of those guys. And then after that, we have that second underscore, we have M or a F. So it's going to be gender. So gender equals, here we can put a dot to match any single character. And then after that, we can match the ages as just, I guess, if we look at all of these guys, it's, well, so we can just put dot star for now. they all seem to be digits, and we'll match those digits later, but let's for now just use dot star. So what happens if we do that? So let's call that who.tall. And when we execute that line of code, we get a result who.tall, which is a new data table with same country ISO year columns that we had before, plus new columns diagnosis, gender, ages that are defined using the values that were matched by a regular expression pattern, and the value column, which is defined using the values in the initial input data set. So, one thing that we might want to do is, we might want to have some kind of more complicated pattern that that actually matches the min age and the max age, right? So how would we do that? So in this case, basically we would have to edit this ages group. So instead of matching anything, we can think about matching a more complicated regex, where here I'm making a list sub pattern where inside of this list I'm gonna match the min and the max ages that are given there. So let's just look at those values that are in there so we can see what we have to deal with. So here, the different values are 0, 14, 15, 24, blah, 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 or 65. So I guess the 65 here is the lower limit and there is no upper limit. So how are we going to write a regular expression that matches all of these guys? Well, so one way to do it would be to say either we match a 0 or we match 2 digits as the minimum. So let's try that. So one way to do that, so let's say here we either match a 0 or 2 digits. So that will be our min age, or maybe we call it min years. Yeah? And that's always going to be an integer. So we can already put an integer type conversion function here in our pattern, and we'll get an integer output. And then after that, our max years, it's also going to be 2 integers, but optionally, right? Because in the last case, maybe there are no 2 integers, right? So here we can do 0 or 2 integers. And let's see what that gives us. So here, well, that gives us an error because we have some problem with no equal sign here. Let's try it again. So who tall now? Let's see if we can actually see all of these columns. So now we have something that is got not just the ages column, but also we have a min years column and a max years column. And if we look at the types, you see that the min years and the max years columns are actually are actually integers, right? So the only thing that is a little bit undesirable here is that here we have missing values for the max years, but actually what it means, when we have just the 65, it means 65 or older, so it would maybe be more appropriate to put infinity instead of a missing value for the max years. So here, instead of as integer as a type conversion function, if we wanted to do that, we could use an anonymous function that says if else x equals the empty string, which that's what it will be if there's nothing matched there. then use infinity. Otherwise, just use as numeric x. Yeah. So using that type conversion function, let's see what we get. So using that type conversion, we see that the min.years column is the same as before. Max.years column now has values 14 through infinity. And so to actually, look at the types, we can look at the structure of that R object. We see max.years is numeric, min.years is integer. And after that, we can also maybe do total table min.years, max.years to see what the values look like. So we can see that the min.years takes values between 0 and 65, max.years takes values between 14 and inf. Pretty cool, huh? Okay, so that was a little bit more complicated example of how to use capture melt single. Again, that function, it takes as input a data table, a wide data table with lots of different rows and with lots of different columns, and with each column having different things encoded in each name. Here it had diagnosis, gender, and these age variables encoded in each column name. And the output that we get is this kind of taller data table here with additional columns for every one of the capture groups that was specified in the R code. And yeah, so thanks for listening, and hope you learned something about reshaping data using regular expressions.